Ranak everybody, we continue to talking about editing real geometry, and on the last video we created something like this. This is original geometry and default mesh for original geometry, and this mesh for changed geometry without all small fillets and objects that affect mesh. So you can see how it look like here, 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 and here, and so on. But we today will talk not with this geometry, but with second geometry. This is our geometry, which is called tripod STP. We announce that we will work with this geometry, and this is how it looks. So this is geometry of classical tripod for camera and many other things. So let's try to do mesh. And while we waiting the end of creating mesh process, I say that unfortunately I can't add a link to original files, but I can say that you can find it on a site which called grabcad with name Lego man and tripod. So also I can say that I have a Patreon, and on this Patreon I published a lot of materials that can be useful. For example, a presentation which I used for creating videos, models and links for them, and so on. So if you like my channel and like things that I do, your help, your support will be very, very important to me, especially in reasons that I live in Ukraine and we have a war today. So additionally, I need to say that on the channel FEArytales there are some real streams where I show full process, live process of editing some geometry for obtaining good mesh, and live process of creating some calculation and so on. It will be much more during time, so you can find not only basic process and basic understanding, but full process with all my glitch, bugs and so on, with all bugs and glitch of software. So you will see how it works and how much time we sometimes need to obtain some results. Okay, we wait a couple minutes and we get result, and we see that a couple objects are not meshed. This one and this one. They don't mesh in reason that we have small objects engraving here, here, and here. But you can see that those geometry have a lot of geometric faces and details. And mesh tried to do the best and get all details on mesh. Sometimes it deletes some details. For example, here it deletes those small faces. It merge nodes, but sometimes it can delete it and you obtain something like that. There are a lot of details from geometry, a lot of unnecessary elements, so you need to do something to obtain better mesh, because this geometry have 1 and 2 millions of nodes and half of million elements. I will not show full process today. I will show only a couple things, but we'll see. Let's open this geometry in Discovery, and also we need to talk about some objects. As you see, this object have a lot of facets, a lot of chamfers, a lot of holes and small fillets. Also, it has object like this one, hide all other bodies. It's a thin-walled object, and the reason for creating good mesh, we obtain something like that. We will have a big number of videos, big playlist for creating mesh and for mesh an object. But today we show some small tips which can help you in creating different simplification of mesh model and changing mesh size. Okay, this is our geometry, and as we do it on a previous video, we can select something. For example, this one, we can use power selector for create, for example, this depression or this protrusion, and can delete. Or, for example, select all faces with the same area. We press delete, and after some time we delete them. Also, we can delete those two chamfers, for example, because we don't need it. And you see that we obtain much more simple object. Something like that we can do here. So we select all faces with the same area. We delete them. Let's find this one. We can't delete those faces in reason that we have face here small, but we can select two these faces, click refresh, it try to calculate, and we can click face with the same area, face with the same area, and delete them. So it's very cool. On an old version of Space Claim, sometimes you can't do this in this way, but try to search and you will see. With this one, we can do in several ways. One of more simple, it's to select all this object and delete. For this one, we can select something like this, click several times, delete, and we obtain solution. With this object, it will be much more difficult, so we open this component. First of all, we delete all this object, then we delete two of this chamfer, and now we select something like this. And as you see, it selects not only face that we need, but face that we don't need. In number are less than face we need, so we delete, and we do it very fast. Okay. Do you need to delete some objects or not? It's your decision. It depends on what type of task you solve and so on. So there are no one solution to all tasks. Okay, what else? Let's open this geometry. Sorry. Open component and show some problem of automatic solving process. It has two objects, as you see, and we copy them and create new version. And let's do something with those objects. First of all, we can delete some features here. For example, we can delete those holes, and as you see, we have some problem here. So we, for example, can select those one, delete, and now we select one of these rounds. We click refresh. It helps us to select all rounds. We click delete. We need to wait some time. And we have some problem. Okay. Let's try to do it in other way. We select those one. Delete. And there are no problem. Imagine all fillets 0.5 millimeter, half of millimeter. We select those fillets and create selection list based on those filter, and we have a problem. We select based on this one, and it doesn't have problem. But let's try to do it with this one. So we select, double click this one, we select all this, we select delete, And we must have a problem, but maybe not. Yeah, we have problem. So we do it in the same way as here, and we have problem. Why we don't have here problem, and we have problem here? Because here we delete one of this round by our hand, and it change numbers, it change range in which it change way in which it delete all these rounds. And here it will delete first of all these rounds, and only then delete this one. And on this model, it's do in other way. First of all, it delete all these features, all these rounds, and as we see here, it gives to us some problem. And it's problem much bigger. So we have a problem which we need to solve. And if we do it here, for example, by selecting this one, searching all bodies and say, please select all rounds on all bodies, waiting. This is kind of magic. Refresh. Oh yeah, it's calculating. We need to wait. It needs a lot of time because we have a lot of different objects, a lot of parts. Okay. And as you see, we can select a lot of object with only one point here. And if we will delete all of them, it will delete it in automatic way, and we can obtain problem like this. So let's try to solve this problem by our hand, step by step. We delete all those rounds, and now we have this object. We double click on this one, and it selects all fillets. And now we need to click this one and this one, additional surface that created not in proper way. And we have, as you see here, one extra edge And sometimes we have here some problem. Maybe we will see it later. Let's try to do it. This one, and sorry, and this one, delete. Okay, something like this. And even without this H, sometimes it's present. Let's select this one, this process called pixel hunting. Okay, we select all these objects and we delete. It's almost done. Dot. Okay. And the last one from the list. Pixel hunting, zoom in, zoom out. Okay. And we have some problems, you see. And I can say stay it real after deleting this object or not. Sometimes it stay. Oh, how we can do it? We can select this object. We can add a dimension. Oh, just a moment. We need to delete this one. For simplification process, we add 1 millimeters and sorry. And we add 1 millimeters and we minus 1 millimeter. And solve all problems that we must have. Just a moment. Nope, it will not. Delete. Okay, just a moment. Will present. So for now it doesn't have any problem, but sometimes we have some problem and we can solve it with changing size of this cone or cylinder. We'll do it bigger and do it smaller with one dimension. But the reason that I say, why I want to say, this is one solid and this is two solid. When we change those diameter, we combine those two bodies into one. So be careful. For today, it's not a problem because we can say split those body with those surface and we obtain two objects as we have here. But sometimes we need much more different step that we need to do for do process better. Okay, these two objects we can delete because sorry, these two objects we can delete because we don't need them. This our good object, we can delete here, facet, so on. So we show some process of simplification, and now we do something like that. Show all bodies. This object doesn't have mesh, so we don't try to see number of mesh. But for some other object, for example, for this object, go to corresponding bodies in tree, and we can see statistic. It's 700 of nodes and 400 of elements. This one, for example, 31,000 of nodes and 16,000 of elements. This one, mm, 400 of nodes and 200 of nodes. Let's check this one. 4,000 of nodes, and let's check, for example, this one. 70,500 of nodes and 9,000 of elements. Okay, we return here. Also, we delete all those rounds. For simplifying process. Okay. Now we update geometry from source. Wait some time. Some objects will not update it because we don't change them. And some objects, as for example this one, will change it. We remeshed all this object and see a result of our simplification process. Sorry, it's not my fault. It's a black screen. Maybe it's a minute for advertising. So if you are watching this video for this moment, maybe it's interesting or helpful for you. So please came as Patreon, but it's your decision. You can stay thumbs up and say like, you can write a comment, or for example you can say that you don't like this video. It's your decision. But supporting this video with reactions, with commenting, with questions, supporting me as creator will help for creating new and better video, for buying more powerful computer and so on. So this is our object. This is our object, and I will not create mesh for all part. I will create mesh only for some part. And we will see the size of mesh for them. Generate mesh on selected bodies. We see how it looks. We have 70,000 of elements here, and now we have go to corresponding bodies and tree. Only 1,000 with a couple. And something like that we will get on all other objects. We can see a mesh here. Generate mesh and select borders. And it's 1,000, also 1,000, not 4. And with all other objects we can do something like that. We generate mesh for this body. We go to corresponding bodies and tree, and also it only 2,000 of elements. Let's create oh, I see. Sorry. It closes geometry, so we update geometry. Update geometry from source. It will appear here. Made in GDR. Okay, this object, and let's create mesh. Let's create mesh, generate mesh on selected bodies. And only 4,000. Yep, it's not very good, but we can improve it. And if we want. And as you see, it can't create mesh in reasons that we have a lot of small elements with engraving, for example, and it can create mesh for a lot, and here we create mesh and it only 4,000. Okay. Additional information that I want to show, it's this one and this object, for example. This object and this. Okay. Let's hide the other object. And let's create mesh for all those objects. And you see our mesh. And if we take this one, go to corresponding bodies and tree, we will see 6,000 of elements. This one will give 6,000 of nodes, sorry. corresponding bodies and tree 4000, but you see how good this mesh are. It's oblivious. Okay, and something like that. And also show all bodies. We have, for example, I don't remember which one. Maybe those. Let's generate. Yeah. And let's take a look to this object. Hide all other object, and we see something like that. And this object, go to corresponding bodies and tree, 24,000 of nodes and 4,000 of elements. So it's very huge mesh for this one object. Let's do some changes. We need this one object, we need this one and this one. Hide others. Okay, let's open this component and take a look. We can delete those faces, chamfers and fillers. If we need, we can reuse it, but we can delete it also. Okay, this one, and okay. And now let's do some changes to obtain better mesh. First of all, we need a plane to see what do we have here. And we see something like that. And we also need to delete those and yep, that's all. Those object. Okay. Delete. And now we can split this geometry, split this body with this one and and with this one, with those two planes. Okay, we split them, and now hide. We create here plane, and we move this plane up to here, and we split those geometry as those object. Okay. Now we can delete those round. We cannot delete, it's our decision. We can split all geometry with this plane for better meshing or not. It's also our decision. And let's do something like that. Additionally, maybe I would delete this face for more simple process, something like that. Sorry. No merge. Forgot. Okay. And now let's do some changes also. With this geometry, we open this component. If we need points here, these holes, we will have them, but for some reason we can delete them. But we also can do this in other way. Plane. Move this plane, for example, on a 5 millimeters. Split those body with those and those face. Move this one up to for example here we split those body with this one, and also we select all these chamfers and delete them. Okay, and the last thing that I need to do is to split those geometry with those faces. So now we create a splitted geometry. What it will give to us? Just a moment, we will check that we need all geometries that we change. Let's do it in another way. Okay, we have all. So show all bodies. Update geometry from source. And we have much better mesh for those objects, but it will be inconsistent mesh. If we want to create consistent mesh, we need to do some additional changes with this object. We need to find this object or open it here and say that we must have shared topology. We'll do it later. So, okay, we don't. Yeah, we have all geometry, and let's see some changes. Let's create mesh for those objects. Generate mesh on selected bodies. Bingo! As you see, we create mesh. And this is what it means, it's inconsistent. nodes are not consist one to each other on different plane, but it can be solved. Okay, but this object have a lot of elements, almost 20 or 30,000 of nodes and 5,000 of elements. How to simple it? Methods, select this one and change from automatic to sweep, and change from automatic sweep to automatic scene. Generate mesh on selected bodies, and we see less number of elements. Yep, for now it's not very good. For now it's look like I don't want to tell this term, but it's not very good. But we can add a sizing and 10 millimeters, for example, and we can go to generate mesh. Okay, 10 millimeters may be not really good. Let's 8. Generate mesh. Okay, and let's do additional things. Yeah, look how cool it is. So, and in this way we can do it with all our features, with all our objects. And as I say previously, we can click here on the name of subassembly, click here, analysis, share topology, and now update geometry from source. Oops, sorry, we need to return to this tab. Update geometry. It's my fault. Okay, and let's do some changes. Let's select this object. Let's generate mesh. Okay, we lose our application. Oh, sorry. Sweep method for this object, for this object, and face sizing for this face. Okay, choose this one, select generate mesh. Also we generate mesh for this object, and generate mesh for this object, for all objects from one part. And we see, for example, here that we have very different mesh, but it's consistent. So something like that. If you want to see a mesh tutorial more quickly, if you want to see lessons about Ansys meshing more fast than it came in general course structure, please help this project FEArytales to grow. Please be Patreon. So that's all, folks. See you later.